This video is an introduction into the X-ray diffraction experiment. So what we're going to be doing is we're going to be using X-ray diffraction to understand how the structure and composition of crystals influences the direction and intensity of diffracted X-rays. So the experimental apparatus consists of an X-ray source, and then over here what we're going to be doing is putting the crystals onto a rotating plate, and there's a Geiger-Müller tube here which is going to be counting the X-rays that are diffracted at different angles, and we can use this to determine the composition of the crystal structures. Here we have 3 crystals, sodium chloride. Each of these crystals have been cut in a different orientation. So what we're going to be using the X-ray diffraction to do is to try and identify which orientation these crystals have been cut in. So sodium chloride is a face-centered cubic structure, and as we rotate the incidence of the X-rays on the crystal, we should be able to see the diffracted peaks. Next we'll be using powder diffraction. So this is the crystal, it's just been ground up into a fine powder. So because of each particle will have a random orientation, every set of lattice planes is going to be capable of reflection. Next we will be using the Lau diffraction method. So for the Lau method we're going to mount a crystal here and then use an X-ray camera to observe the Lau spots that are diffracted through the crystal. So we have a crystal holder here which is going to focus the X-rays onto the crystal for us to detect through the camera. So to begin with, what we're going to do is do a calibration image without the crystal, and then after that we will put the crystal in and have a look to see if we can observe any Lau spots. Now we insert the crystal onto the diaphragm and put it back in. As you see, we're starting to observe the Lau diffraction pattern.